Assalamu alaikum warahmatullahi wabarakatuh. This is Abdurrahman Danri, and in this video, me and my friends, we are going to talk about disk scheduling algorithm. This video is based on the course of operating system with Dr. Ahmed Faris. You know there are a lot of scheduling algorithm, disk scheduling algorithm, but we are going to talk about the most common one, which are lock, C-lock, scan, and C-scan. Let's start with introducing the disk scheduling algorithm. Disk scheduling is crucial in operating system for managing read-write head movements on hard disk. It aims to optimize the performance and reduce the seek time. So, why it is needed? Disk scheduling algorithms are needed because a process can make multiple input-output requests and multiple processes run at the same time. The request made by a process may be recorded at different sectors on different tracks of the disk. So due to this, the seek time may increase more. These algorithms help in minimizing the seek time by ordering the request made by the process. So we have here the case study. We are going to explain this algorithm based on this case, in this case study. We are going to take the case study of operating system virtual memory management. Overview of the case study. Operating system use virtual memory to extend the available physical memory of a computer. This involves paging, where the memory is divided into fixed size pages, and the operating system manages the swapping of these pages between the physical memory and the disk. Efficient disk scheduling algorithm crucial in managing these operating so ensure some smooth and fast access to data. Implementation of disk scheduling algorithm. Assalamu alaikum warahmatullah. This is Abdurrahman Danri, and I am gonna present the scan algorithm, which is known as elevator algorithm. We are going to know why it's called elevator algorithm. We will take examples based on our case study, but first let's start to know how it works. The scan algorithm moves the disk arm in one direction, serving all the pending pages request until it reaches the end of the disk. Then it reverses direction and continues serving requests. This is why it's called elevator algorithm, because the arm will move in one direction until the end, serving all the requests in the way, and then it will go back and also serving all the requests. The operating system maintain a list page requests that need to be loaded or written to disk. This is based on our case study. Scan ensure that the disk arm serves all requests in one swap, minimizing the seek time and reducing the number of head movements. This is particularly useful in scenarios where there is a high demand for memory swapping. So let's see the example. Suppose the following queue of virtual memory pages wants to swap from RAM to the disk using scan algorithm 45, 150, 85, 33, 110, 10, 50, 90, with the initial position of the head at 50. So initial position at 50, and we want to serve the head move. We want the head want to move and serve all these virtual memory pages. So this is represent the disk. This is the request, and this request is in sectors inside the disk, inside the platter. So the initial position will be at 50. This line represents the movement of the head. So based on the scan algorithm, the head will move in one direction, serving all the requests. As you can see in 190, there isn't any request, but it has to move until the end. Then it will go back and serve the request, the remaining request. So let's calculate the distance. The distance will be the last position minus the first position for this movement, and the second movement the same, 90 minus 85 plus 898 minus 90, and so on, and this movement will be 217 cylinders. But let's take another example where a new request enter the queue in front of the head on the way back. Let's take the same example but with new request in the way back in front of the head. So initial position at 50, the head will move until the end, serving all the requests. Then in the way back, as you can see here, 130 and 40 just enter the queue. So based on the scan algorithm, this request has to be served in the way back of the because it's in front of the head. It has to be served. So it will serve 130 in the way back, and it will serve 40, and then it will serve the 33, the last one, and the the movement calculation will be like this. So the total is 237 cylinders. That's it about my part, and now my friends will explain the C-scan algorithm. Thank you.
Good day everyone, I'm Jihan from OS Group Project Group 1. Now I will talking about C-scan, which is circular scan algorithm. C-scan works like scan, but upon reaching the end of the disk arm returns to the beginning and starts servicing requests from there. The OS queues page request and service time in a circular manner. By jumping back to the start after reaching the end, Cscan provides a more uniform wait time for page requests. This prevents starvation of requests and ensures a balanced load on the disk. Let me provide an example for Cscan algorithm. There is a disk drive with 200 cylinders, which is from 0 until 199, and there's a request queue which is 98, 183, 37, 122, 14, 124, 65, and 67, and the head pointer is 53, as well as the direction is the this arm is moving to innermost. As we can see, this is the visualization of the C-scan algorithm, and the total is distance is equal to 65 minus 53 plus 67 minus 65 plus 98 minus 67 plus 122 minus 98 plus 124 minus 122 plus 183 minus 124 plus 199 minus 183 plus 199 minus 0 plus 14 minus 0 plus 37 minus 14, which is equals to 382 cylinders, which is the head movement. That's all from me. Thank you very much.
Good day, everyone. So today I would like to present about my OS project, which is this scheduling. So my group members will present their own algorithm that is listed in this scheduling, which is scan, C-scan, look, and C-look. And now I will present about my look algorithm, with another name is called advanced scan algorithm. So how it works is look operates similarly to scan, but instead of moving the disk arm to the end of the disk, it changes direction when there are no more pending requests in its current direction. The OS queue pages requests and handles them in back and forth fashion. By reversing direction when there are no further requests exist, look improve the efficiency of servicing page requests. This prevents unnecessary movement of this arm to these edges, ensuring a balanced load on the disk. So now we will look at some example. So this is an example of load algorithm in OS operating system, which is what my group will be using as a real world application. Since OS is very common in laptops and devices, so this is the load algorithm. So we have input. This is the request sequence 176, 79, and the initial head position will start at 50. So the direction it will be provided, which is right. So we are moving from left to right. So the output, the initial position of head should be at 50, and the total number of seek operation is 291. So this is how the algorithm should work. So as you can see, the red dot signifies the initial head at 50, and after that, from 50, it will move right since the initial direction is from left to right. So from 50, it will move to 60, and then it will move to 79, and then 92, 114, and 176. As you can see, when after 176, there is no more requests on that direction. So now if in loop algorithm, it will reverse the direction from right to left. So our next request is on the left side, 41. So for 176, it will move left to 41, and then it will stay in that direction until our final request, which is 11. So from 41, it will move to 34, and then finally stop at 11, which is the last request. So the total state operation will be calculated like that, like 60 minus 50. So you, from the initial position to the next position, you just subtract from the initial position. So total is 10 plus 19 plus 13 plus 22 plus 62 plus 135 plus 7 plus 23 equal to 291 cylinders. So that's all for loop algorithm.
Okay, Assalamualaikum warahmatullahi taala wabarakatuh. So today I will introduce to you what is C loop, which is circular loop. How it works like loop, but instead of going back at the last request, C loop goes back to the beginning and keeps going in a circle. The operating system arrange page requests in looping. So it is using of looping queue, minimize seek time. The disarm hops back to the beginning after serving the last request in one direction only. This method guarantees that no page request experiences starvation, resulting in a steady performance. So let's look at the what we call wait, the example. So for the input, we request the request sequence is 176, 79, 34, 60, 92, 11, 41, and 114. And the initial head position is 50, and the direction right moving from left to right. So the output initial position of head is 50. So we start with 50. So the six sequence is 60, 79, 92, 114, 176, 11, 34, and 41. So the total number of seek operation is 321. So we sum all of the seek sequence. So we got 321. So from this, we know that we start at point 50 here. So we start at point 50, and then after that is going to be 60 because the sequence here is 60, then 79, 92 because here we can see 92, and then 114, and then 176. But after that, we need to back to the 11 again because there's no other numbers that more bigger than 176. 176. So we're here 11, and then have 34 and 41. So 60, we total seed count is 60 minus 50. As we see, 60 minus 50 is 79 minus 60, 92 minus 79, 114 minus 92, 176 minus 114, 176 minus 11, plus 34 minus 11 plus 41 minus 34, and it's equal to 321. So here we got the total number of six operations. Okay, that's all from me. Thank you.